Alright, today's video lesson is on probability. We're just going to go over a lot of definitions and formulas pertaining to probability. So let's get started. Alright, so probability. The probability of an event is the proportion of times the event occurs in the long run. So over time, it's the probability that something's going to happen. The law of large numbers basically says that you can expect that probability or that proportion if you looked at a large amount of trials. That means if I had an experiment and I repeated it again and again and again and again and again, I can expect the proportion or the probability to approach whatever number I thought it was going to approach. For example, if I was flipping a coin, I know that the probability of flipping heads is 0.5. Now, if I flip the coin 5 times, I might not get, or let's say 6 times, I might not get a probability of 0.5. I might get something smaller, I might get something more. I might flip heads more than 50% of the time, or I might flip heads less than 50% of the time. That's expected in the short term, but in the long run, I would expect the probability to be 0.5. So if I flip the coin maybe 5,000 times, I'd expect that about half of the times they were heads. So again, probability only works in the long run. It's not going to work in the short term. You just have to keep that in mind when you're doing problems. It's about the far off. It's about the long run. It's about me repeating it over and over and over again. What can I expect? Not doing it a couple of times. All right, so your sample space is all possible outcomes. All right, it's not a specific outcome. It's every single possible outcomes that I can get in a particular experiment. Your event is whatever probability you're specifically looking for. So if I was rolling a die and I was specifically looking for the probability of getting the probability of rolling a 3, then my event is rolling a 3. So when you put it all together, your probability model is all possible outcomes as well as the probability for each event. So I'm looking at all of the possible outcomes that I can get, plus I'm looking at each little event in that sample space, and I want to get the probability for that. That's usually written out in a table so that you can see the entire sample space and the probability of each event. Alright, so this is your formula for probability. And this formula specifically pertains to equally likely outcomes. So if you know your event, that's going to go in the numerator. That's the number of outcomes in A. That's the event that you're looking for. And then your denominator is the number of total outcomes. So it's the number of outcomes in your sample space. When you divide that number out, you're going to get the probability of that event. All right, so to sum it up, your probability is always between 0 and 1. If you have a probability of 0, that means that the event cannot occur, like it can't happen. And if you get a probability of 1, that is the probability that means that it is most certain to occur, like it's definitely going to happen. So again, 0 means it can't happen, 1 means it definitely will happen. When we're talking about probability, we're typically looking for to see if something is unusual. And so when a probability is really small, we call that an unusual event. Now, there's no hard, fast number that we use as a small number. All right, it really just depends on the scenario. But most of the time, and for this class, majority of the time, we're going to use 0.05 as our cutoff. In other words, if the probability that we find is less than 0.05, we say that is very, very unusual. If it's greater than 0.05, then we say, okay, that's likely to happen. It's okay. Now again, depending on the scenario, that number can change. Some people use 0.1, some people use 0.01, but for most of the time, or for most people, we use 0.05 as our cutoff. All right, the empirical method consists of repeating an experiment a large number of times. So how is this different? Well, basically, the empirical method is generally used when you don't know the probability of something for sure. Usually in real life experiments, like if you want to know the probability of you getting lung cancer from smoking cigarettes. Well, I don't know what that probability is. We don't just know it's not something that's known as not something that we could have just calculated. So what we do is we repeat an experiment a large number of times. We kind of see the trend, and we're able to approximate our probability using the experiment and using the trend that we saw in the numbers. Alright, so a compound event is when you're combining two or more events. So it's like the probability of this happening or that happening. It's the probability of rolling a die or rolling a 6 on a die, or the probability of flipping heads. So at the bottom is kind of like your formula. The probability of A or B is the probability that A occurs or B occurs or both occurs. So you have to remember that for statistics, we're looking at A or B or both. Alright, with that being said, we have an actual formula, a numeric formula for this. Probability of A or B is the probability of A plus the probability of B minus the probability of A or B. That's the probability that A happens plus the probability of B happens minus the overlap, minus them happening together. Alright, if two events are mutually exclusive, that means it's impossible for both events to occur. It's like if I ask you the probability, or if we're looking at being a male or a female, you can't be both. Alright, you're either a male or a female. So those two events, the probability of being male or the probability of being female, they can't happen together. Like you cannot be both a male and a female. So we say those two events are mutually exclusive. If I say something like the probability that you're in Texas or the probability that you're in California, well, at that instant, it can't happen together. So we say those two are mutually exclusive. If two events are mutually exclusive, they have no overlap. So when I take my OR formula or my general addition formula, instead of having that minus piece at the end, I just have the probability of A or B equals the probability of A plus probability of B. Again, I don't have to worry about the overlap in the two events because they couldn't happen together anyway. If I'm looking at three or more events, it's the same formula holds true. You just add up all of your probabilities and you get your answer. You don't have to worry about subtracting off anything. You don't have to worry about any overlap because, again, those events are mutually exclusive and they can't happen together. Alright, so the complement is the probability that something does not occur. A lot of times this is useful when doing calculations. So if you want to know, say for instance, the probability of you winning a race, sometimes it's easier to find out the probability of you losing the race. So instead of calculating the probability of winning and doing a whole bunch of crazy calculations, if you could find out easily the probability of losing, well then you just do 1 minus losing, and that will leave you with the probability of winning. So again, in using a complement, if it's easier to find the complement, to find the probability that something doesn't occur, you'd use that, subtract it from 1, and you get the probability that it does occur. Next, we have our conditional probabilities. A conditional probability is the probability that something happens given that something already has happened. So what's the probability that it rains given that it rained already 3 days this week? What's the probability of me eating my vegetables given that I haven't eaten vegetables in the last 10 years? Something like that. You're looking at the probability of something knowing that something else has already happened. Now, we do have a formula for your conditional probabilities. It's the probability of B given, this straight up and down line means given that A has already happened, is the probability of A and B over the probability of A. So again, you want to use this formula only if they specifically tell you that something has already happened and the probability that you're looking for can change or is influenced by that probability of whatever else that had already happened. Alright, so again, if you have something that's depending on something else, you use your conditional formula. Alright, with that being said, we can come up with, or we can really revise that conditional formula, rewrite it to get our general multiplication formulas or general multiplication rule. So the probability that an event A happens and an event B happens is the probability that A happened times the probability of B given A. So again, nothing really different here. It's taking that same conditional formula and it's just rewriting it to get the probability of A and B. Alright, next we have independent. So if two events are independent, if the occurrence of one event doesn't affect the other. So the fact that one event happened does not affect the other event, we say they're independent. If they're not independent, in other words, they do have an effect on each other, then we say that they're dependent. This is important when doing a lot of calculations because you need to know whether or not the events are independent or not. If they're independent, then that whole conditional idea kind of gets thrown out the window, because if they're independent, well, the fact that one happened doesn't matter that the next event happened. Like, it's not affecting the next event, so I don't need to worry about the whole conditional part of it. Alright, so given that two events are independent, we don't have to worry about the conditional part of it, the whole given that part of it. So if we want the probability of A and B, it's just the probability of A times B. And again, if I had more than one event or more than two events happening, we would just multiply all those events out. So again, I can do it for like 3, 4, 5, however many events I want. If they're independent, I simply just multiply it and call it a day. So again, the formula is a lot easier when they're independent, but you need to determine that before you actually start working the problem. You need to figure out whether or not they're independent or not, so that you know which formula to use. If they're independent, use this formula. If they're dependent, then you use the other general multiplication rule.